Hey guys, welcome back. Quick update on the electronics. I've been giving it some thought on what kind of components I need and how to connect them. What's the order in which these will be connected? So I've been working quite hard on this, and I'm going to explain to you what's actually going on here. It might look a little complicated the way I did it, but I'm going to make it simple for you guys. So let's go through them one by one and see why these components are placed where they are placed. So this is obviously the battery pack, and that's where we left off last time. So let's draw that first. That's the battery pack. And obviously here you've got two wires coming off, the positive and the negative. So that's the positive, that's the negative, and there's another wire here which is the charged wire, so let's call that C minus. Now the first thing that comes out of the positive wire here is the charger, or the female XLR charger. The way that's connected is it's connected to the positive, and then it bypasses the negative. It's not connected to the negative, and then it connects to the charge minus. And here you have your charger. Now that's the first thing connected to the battery. And we'll come to the reason why this is connected first and not later on in the chain. And then as you go forward, let's see, as you go forward right after the charger, you have this thing which is a fuse. So if I open this up, there is a 40 amp fuse, and this is like a car fuse. So if I pull it out, it's just like a normal car fuse, and it's rated for 40 amps. And obviously you can have your own fuses of any number of amps you want, but I thought 40 amps would be a good limit. And that's kind of the first thing you want to have connected to your battery. So if anything goes wrong, this fuse blows, and anything after the chain doesn't work. And that's exactly what you want. Or if anything goes wrong and the fuse doesn't blow, you can just open it up and pull the fuse, and then this will be disconnected and nothing after the battery would be affected in case your battery shorts or anything like that. So the first thing here would be the fuse. Let's call it F, and that's the way it's connected. It's not connected to the negative of the battery. And then after the fuse, what I have here is this XT60 disconnect switch. It's like a pull switch, or like an emergency switch. If anything goes wrong on this side of the setup, and the battery isn't blowing up because it's not exceeding 40 amps, but if there's a spark here, a short circuit, you can manually just pull off the XT60 wire, and it will disconnect everything from the battery pack. So that's like an additional safety mechanism. You don't need to have that, but I like to have that anyway. So this is the XT60 fuse, and that's how it's connected. Once you pull it out, it disconnects this part of the battery and that part of the setup. And let's see, after the fuse, you have this flick switch, which is really cool. I like flick switches. So let's say we have an on-off button, which is again not needed, and obviously it's gonna be hard to fit it in the OneWheel because I don't want to be on the rails and spoil the look of the OneWheel, so I'll have to hide it somewhere. But again, this is just a switch in case you want to disconnect anything manually. You don't want to you don't want to keep pulling and pushing the XC60 connector if you want to switch it on and off. So this is like an easy way, the go-to button for switching it on and off. After the switch, you just have the output, which is connected to the negative of the terminal, and this goes to the VESC here, the XC60 connector of the VESC. So we're finally having the output of the battery to the VESC. So the way this is connected is, you should have noticed that we haven't connected the negative yet to any of these components. Now this one goes to the VESC, right? An XC60 connector to the VESC. So basically that's how it's set up, and it's really simple. And you might say that all this is not needed, and you might be right. You might not need the fuse, you might not need the XC60 connector or the on-off switch button, but I like to have you know, additional safety in place just in case something goes wrong. You don't want to have a battery which is putting out hundreds of amps and can potentially catch fire without any safety mechanism in place. Now, in addition to that, there's some more stuff, which is this guy. This is the battery capacity meter. So if I switch on the battery like that, you're going to see 100% capacity, or about 40 volts. And then one thing that the OneWheel, the real OneWheel, is missing is a battery capacity meter on the OneWheel. It's got a Bluetooth app that tells you the battery indicator, but we still don't have that Bluetooth application on our OneWheel. So I'm going to have to mount this somewhere on the OneWheel so I can look at the battery percentage all the time. And the way this is connected is this is connected right before the XC60 connector here. So right after the fuse and the XC60 disconnect, the next thing that's connected is the battery indicator. So it's somewhere here, and the way it's connected is it's just connected to the positive and the negative. So that's the battery indicator, and that's how it's connected. And then this guy is the buck converter. And if you don't know what a buck converter is, it just takes a high voltage and then outputs a lower voltage, and then this is adjustable. You can rotate this potentiometer and then adjust the output voltage. So where this is connected is right after the on-off switch. We have a buck connected to the positive and negative terminals. So this is the input to the buck, and then there's an output, 5-volt output coming out of the buck converter. Now the reason we need that is, yes, obviously the VESC has its own 5-volt power supply, and you can connect one of these. I think the one in the middle, that's the 5-volt power supply, and you can connect your Arduino to this and it'll power on your Arduino, and that should be perfectly fine. But the reason I have a buck converter is because I needed to power, one is the Arduino, and I might add some lights in the future, and obviously you can't run the lights off the VESC because they might draw too much current and ruin your VESC. So you don't want a $100 component to be ruined just because your lights pull too much current. So it's better to invest in a $2 buck converter. Also, I have one of these power switches which is lit up with the 5 volts from the buck converter. Again, I didn't want to light this up using the VESC, so the button is another one. And also, if you want to add Bluetooth functionality in the future or other 5-volt components, it's good to have a buck converter on hand, and you can just add stuff to it. So right now the 5-volt rail is going to the Arduino and to the button, and it might go to the lights in the future. Now let's talk a little bit about the sequence of the components and why they are placed where they are placed. Obviously you want to have your charger first because even if something goes wrong here, it doesn't matter. I still want to be able to charge the battery. So the charger comes first in line. And then the first thing after the charger is the fuse. If something goes wrong, I want the fuse to blow first instead of any of these components blowing up before the fuse. So that's why the fuse is here. And then there's the XT60 connector, which I want to have as an emergency switch. So if something is going wrong, I want to pull the switch and then disconnect everything here with everything on the other side. Then there's a battery indicator. So whenever I switch on this switch, actually the battery indicator is after the switch. So whenever I want to, I switch on the flick switch, I want the battery indicator to show me how much battery I've left. And if you place it here, it'll be always on. So that's why the battery indicator is just after the flick switch. So you can see that here, that if I switch the flick switch off, the battery indicator goes off and the buck converter goes off. So you don't want to have a buck converter here, because then again it'll be always on, and you don't want the buck converter to always draw power from the batteries. So basically all your electronic components, everything that powers on your circuitry, is coming after this on-off switch. This is basically the first step after all the safety. So once you turn it on, the battery indicator goes on, the buck converter goes on, and the VESC goes on, and so on and so forth. So that's basically all the electronics that are involved. And again, you might not need like half of these, but it's always good to have extra safety built in case something goes wrong. Alright, so this is the VESC, and you can see I have waterproofed it very professionally, like Tupperware, and it's easy to work with. I just have to put some hot glue on these ends, and then it'll be almost waterproof. Now this I haven't shown you before is what I did with a proto board. We have the Arduino and we have the gyro, and then there's a couple of other inputs, and what these are doing is these are coming from the footpads, but eventually these inputs are going to have footpad 1 and footpad 2 connected to the analog pins of the Arduino. So these wires are going to the A6 and the A7, and that's a 5-volt input which is coming from the buck converter powering the Arduino, and then that's the ground. This one is connected, you can see, to the digital pins, to the D3 pin here, I think, and this will be the signal to the VESC. So if you can see, your VESC has these PWM or PPM inputs. So one of them is the signal wire, which I think is the first one. Your signal is going to go to this pin, and then the Arduino is going to, whatever it's calculating, it's going to pass the PWM signal onto the VESC via the D3 pin. Now we'll go more into detail on how to make this work, and after we've connected the footpads, but this was just a quick overview of the electronics and how to connect your electronics. So that's pretty much it for today. Thanks for watching, guys. Hope you liked this video. If you did and you want to follow this build, you have to subscribe and click the notification bell. I don't know why YouTube has made that so difficult, but apparently that's what you got to do if you want to receive all the notifications from this project. So yeah, that's about it. I will see you next time.